Ben, could you talk about the new smart radio head announcement you had this week?
Yes. So we have been developing small cell single chip base station on a chip to a lot of LTE small cell market, enterprise small cell, picocell, and above. We are also using that technology to develop a smart radio head. And that smart radio head is one of the new products we announced this week. We are also using that technology in our demo here for the complete live traffic Cloud RAN demo. So in Cloud RAN, basically the mobile infrastructure is decentralized, or a big part of it is centralized. In terms of the traffic flow, we use an example of a user using a tablet trying to stream traffic or stream video from a website. So the user using a tablet is wirelessly connected to the LTE protocol to a remote radio head. So typically this would be a base station at a cell site. As a small cell, this would be a small cell base station in the cell site, which could be an office, could be in some football stadium, etc. In this case, it's a smart radio head, and it is very small. It's powered by only power over Ethernet, very low power. And the baseband processing, which is typically done by a base station, it is split between a smart remote radio head and a centralized baseband processing. So this system is typically called a Cloud RAN server. So when the traffic goes to the cell site, it is related to the centralized Cloud RAN server. In our case, it's only Ethernet, because that's a much more cost-effective way to do it. In a lot of the current trial or prototype deployment of Cloud RAN, this would have been a very expensive fiber optics because there's latency requirement of LTE. In our case, we have some smart processing here in a remote radio head, and that gives much better latency tolerance. So we can use even basic Ethernet connection or IP connection between the radio head and a centralized baseband Cloud RAN server. This Cloud RAN server is powered by Cavium ThunderX ARM 64-bit processor. It is in a standard 1U factor, 19-inch, standard commercial off-the-shelf server, COTS server. It is running Linux application, Cavium. It's running the Cloud RAN, basically baseband processing in virtual machines. And after the RAN processing, it would be going to a mobile core in a LTE architecture. So mobile core is also running on this server as virtual machines. And after the EPC runs, then it sends the traffic to the internet. In our case, we have an app server here, which is serving video. And the video will be going back to the mobile core, Cloud RAN, remote radio head, and back to the user. And this server here, it is based on Cavium 64-bit ThunderX. And the board here is only this very small board, in this standard server. And as you see, this is single chip. It has 48 CPU cores, 4 channels of DDR3 or DDR4 memory channels, 8 10 gig internet connections, a lot of PCIe Gen 3 interface as well, all built into one single small board like this. So the total cost of ownership is much better compared to the typical server you see today.